This is Mission Control Houston. Flight controllers here continuing a contingency operation, securing information and data. The last communications with the Space Shuttle Columbia were at 8 a.m. Central Time as it was flying 200,000 feet above Central Texas, en route to the Kennedy Space Center for a landing. No communications have been received with the spacecraft since. No tracking data of objects of any kind reported by the Merritt Island tracking site and its C-band radar when used to sweep the sky. Flight Director Leroy Kane has declared a contingency. Flight controllers securing all information and data and notes. No tracking reported again of Columbia since about 8 a.m. Central Time as it was descending toward Florida, toward the Kennedy Space Center above Central Texas.
Let's get Kyle Herring back on the line. Kyle Herring is Public Affairs Officer for NASA in Houston. Kyle, what can you tell us?
Nothing new, Miles, that I can report to you at this point. You know, still maintaining the same posture that we were in just moments ago. So there's really nothing new at this point that I can pass on to you.
All right. Give us a sense, Kyle, with your familiarity of this, as a shuttle comes in for re-entry, the sorts of stresses, as we look at this tape one more time from our affiliate WFAA, streaking across Dallas, you see what looks like a streaking comet, a meteor, and then all of a sudden, right at that point, I don't know if you saw it, right as it hit that, went behind that pole, multiple targets there, multiple streaks. Give us a sense of the kind of stress it would be enduring at that point, Kyle, going about 14,000 miles an hour or so.
Well, just based on my experience with a shuttle reentry, you're usually somewhere around 250, 300,000 feet in altitude at that point. So you're back in the Earth's atmosphere. That reentry into the atmosphere really occurs about 400,000 feet, and that's typically out over the Pacific Ocean. Then the shuttle, basically, it's high-speed reentry. At that point, you're probably going somewhere around 6 times, 7 times the speed of sound, maybe. And there's a series of high-speed bank turns that are made by the computers to slow the vehicle down, basically put the underside of the orbiter into the direction of travel to slow it down.
Kyle, watch this tape with me. WFAA gave this to us. And look, right at that point, significant difference right there. Don't you agree?
Oh, definitely. I mean, it's definitely something that occurred that we obviously at this point don't know what that is that caused this.
And then we're talking about stuff that we have here exclusively as we watch this. Very distinct. And do you recall seeing the mirror reentry, Kyle? It's very reminiscent of that.
Yes, it's very similar to what would occur with a targeted reentry of something that was like a progress vehicle that we send away from the station to burn up in the atmosphere, Mir's reentry, Skylabs, and anything like that, yes.
All right, let's talk for a moment about the contingencies which the crew trains for ad nauseum in Houston, which is bailout. What would be a scenario if something was going wrong at this point? What are the options for the crew for getting out if they need to?
Well, I'm afraid, Miles, that there is not really an option at this altitude. The bailout procedures that are in place for a shuttle, either during after a engine problem on launch or on reentry, are bailout procedures that would take place or be in effect below about 20 to 30,000 feet or so. So much lower than what you're seeing here.
And you're saying we're talking 200,000 feet at least there, about 6 times the speed of sound. But what we're also talking about here, Kyle, when you look at all the forces and stresses on a space shuttle from launch all the way to landing, you know, we talk about max Q on liftoff, when the maximum dynamic pressure on the shuttle. When does it encounter the most stress? Launch, landing? Is this the period right here that we're seeing this tape?
Well, launch is probably among the most stressful during that max Q period, because that's when there's the most aerodynamic pressure on the vehicle. In that altitude range on the way uphill, typically there's not a max Q, if you will, on the way down. There are stresses on the order of about maybe 2 Gs or so when you're making the big wide sweeping turn approaching the runway. But at this point, there aren't any stresses in terms of G-forces that you're really feeling, because you're still pretty high up in the upper reaches of the atmosphere. So it's not very thick, if you will, at that altitude.
All right, we should tell you, Kyle, that while you were talking, we're receiving some calls from viewers. Palestine, Texas is the date line. We're about 100 miles south of Dallas, I'm told, and there are reports there of a loud impact. Let's leave that at that for just a moment. Kyle, if you could stand by. Phil Chen, could you describe, you're right there at the shuttle landing facility, describe the scene for me, please? I guess we've lost Phil Chen. I should point out the crew. The commander, Rick Husband, the pilot, Willie McCool, Mission Specialist 1, David Brown, Mission Specialist 2, Kalpana Chawla, Michael Anderson, Mission Specialist 3, Laurel B. Clark, Mission Specialist 4, and the payload specialist, the first Israeli ever to fly in space on this 16-day mission, Ilan Ramon, at the tail end of what was a relatively flawless mission, scientific mission, 16 days in orbit. What we're seeing here is very ominous indeed. These are pictures which tell the story. That is clearly the shuttle breaking up as it passes south of Texas, Dallas, Texas, near Palestine, as it was coming in. Communication was lost about 15 minutes prior to its anticipated landing at the Kennedy Space Center at 9:16 a.m. Eastern local time. Kyle Herring, search and rescue forces in motion yet? Can you confirm that? We've lost Kyle Herring. We can only presume that those same calls that we are getting here are being received with the authorities. And we're joined by a veteran space shuttle astronaut, a man who spent several months on the space station Mir, a man who has experience before and after the Challenger disaster with NASA and the shuttle. Norm Thagard, good to have you with us.
Thanks, Miles. Good to talk with you.
Norm, can you see these pictures? Are you watching CNN?
Well, I could bring it up, but I'm in fact, upstairs where I don't have a TV. If we get a break, I can go to the TV.
Well, Norm, as you well know, because you were with me that night, it's practically a carbon copy of the picture we saw from the South Pacific when the space shuttle Mir came down. Multiple targets, multiple trails behind those targets. Where does that leave the experts now, the engineers? What do they do?
It almost certainly, I would think, Miles, means that the shuttle broke up. It is an electronically controlled vehicle, and if it, for some reason, loses control at those speeds, it's going to be a bad situation.
Let's back up and talk about what could cause a space shuttle to break up at this juncture in its flight. We've been talking a little bit about how it's hydraulically controlled. We know what hydraulics are, obviously, but the shuttle doesn't have any operative engines as it comes in. So they fire up what are called auxiliary power units, run on hydrazine, which power those hydraulics. And those are kind of, well, those machines are something you have to really be careful about, right, Norm?
They run at very high speeds, I think something like 80,000 RPM, and it is possible for, I guess, one to fly apart. However, there are 3 of them, and you can certainly operate with the loss of one. And some of the rockets are used right down to almost the last, just as the shuttle starts to go subsonic. So some of the steering rockets or attitude rockets continue to fire even down close to ground.
Okay, so those steering rockets, how much would they be? They would be used at this juncture then? We're talking about the rockets that are typically used on orbit to maneuver the shuttle. They would be used in the higher altitudes where there's less air passing over the aerodynamic surfaces of the shuttle, correct?
That's correct, and as the shuttle gets lower and lower, I think various of those rockets start to be deselected, and then finally, before the shuttle or right around the time it goes subsonic, none of the rockets are being used anymore.
I see.